Evaluate the limit at x equal to infinity of the quantity x minus the square root of x squared plus x. This is the limit of a difference whose the limit of the first term is infinity, doesn't exist in a special way. The limit as x goes to infinity of the square root of x squared plus x, the second term, inside the radical, this is a very large number because x goes to infinity. The square root of a very large number is still a very large number. So this limit is of the indeterminate difference, infinity minus infinity. So we can use the L'Hopital rule. But before we can use the L'Hopital rule, we need to rewrite this so that this is a ratio, something over something. As of now, we have the limits of the difference, x minus the square root of x squared plus x. The trick when we have the radical is to multiply a well-chosen one. This well-chosen one is the conjugate of this binomial, which is x plus the square root of x squared plus x. But if we multiply x plus the square root of x squared plus x in the numerator, we would need to multiply it in the denominator as well. And again, this is called the well-chosen one. X plus the square root of x squared plus x, top and bottom. This quantity is 1, so it will not change the given limit. We now have the product of the conjugates in the numerator. The product of the conjugates is the difference of two squares, the first term squared minus the second term squared. And the denominator is x plus the square root of x squared plus x. We then simplified the numerator to have x squared minus the quantity x squared plus x over x plus the square root of x squared plus x. And then we distribute the negative sign in the numerator to have x squared minus x squared minus x, and the denominator is still x plus the square root of x squared plus x. In the numerator, x squared minus x squared cancelled out, and we treat this as a new limit. This might or might not the L'Hopital rule. We haven't used the L'Hopital rule yet, but let's see. This limit at x goes to infinity, the numerator is negative x, and the denominator is x plus the square root of x squared plus x. If we were to find the limit of the numerator alone, then it is negative infinity, and the denominator at x goes to infinity is goes to infinity. This is now the L'Hopital form, indeterminate infinity over infinity. We treat this as a new limit problem, and we find the limit using the L'Hopital rule if we wanted to. Although in this case, it is much easier if we evaluate this limit using the pre-calculus techniques. This is negative x over x plus the square root of x squared plus x, and we see that the highest degree in the denominator is x. We then divide by every single term by x, or multiplying 1 over x. With the term that has the radical sign, we would rewrite x as the square root of x squared so that we can combine the radical. Regardless, this is now the limit at x goes to infinity. The numerator now is negative 1. The denominator x over x is 1 plus. To simplify the term with the radical, we rewrite x as the square root of x squared so that the square root of x squared plus x over the square root of x squared can be combined into one radical, x squared plus x over x squared. And then we simplify this further as x squared over x squared plus x over x squared, which is the square root of 1 plus 1 over x. And so the last term in the denominator is now the square root of 1 plus 1 over x, where we simplified it on the side. It is okay to perform the scratch work on the side. But remember, as x go to infinity, 1 over x go to 0. And so the radical alone is now 1 plus 0, which is 1. And so the answer is negative 1 over 1 plus 1, which is negative 1 over 2. We obtain the answer negative 1 over 2 using pre-calculus technique. We have not used L'Hopital rule at all. What happened if we use the L'Hopital rule? At this point, when the limit at x equals to infinity of negative x over x plus the square root of x squared plus x, this is of the indeterminate form, infinity over infinity, so we can use the L'Hopital rule. To use the L'Hopital rule, we would differentiate the numerator, which is the derivative of negative x, negative 1. And then we differentiate the denominator. The derivative of x is 1 plus the derivative of the square root is 1 over 2 the square root, and we multiply the derivative of the inner function of the radical, which is 2x plus 1. And then we simplify this limit. Treat this as a new limit. The limit as x goes to infinity of negative 1 over 1 plus 2x plus 1 over 2 the square root of x squared plus x. This is a complex fraction, so we would need to clean this up. The common denominator of the denominator is 2 the square root of x squared plus x, and so we would multiply 1 with 2 the square root of x squared plus x over 2 the square root of x squared plus x. And with the second term we keep, which is 2x plus 1 over 2 the square root of x squared plus x. We can now combine the two rational expressions in the denominator. The numerators are 2 the square root of x squared plus x plus 2x plus 1, and the denominator is 2 the square root of x squared plus x. And then we rewrite this complex fraction as the limit as x goes to infinity of 2 root x squared plus x times negative 1 over 2 root x squared plus x plus 2x plus 1. As you can see, this is quite messy because this is still in the indeterminate form, infinity over infinity. We might as well use the pre-calculus technique.